So today I'm going to talk about exceptions. Okay, exceptions are things that can go wrong in your Java programs that there's no way to control at compile time, but they go wrong at runtime when you're running the program. So for example, we have this little program here. There's a main method that prints out here, right? So that prints out the result of this function, divide 3, 2. If we go to the function divide 3, 2, it should return an integer. It takes two parameters, two ints, and then it returns the division. So this compiles because it's correct code. And then when we run it, you see the output 1 because it's the integer part, right? So when you divide two integers, only the integer part comes out. So this is like, I don't know, 1.5, but because the integer part is 1, that's the result here, 1. Now, so we can do, 6 divided by 2, then we compile this, and we run it, and we get the result 3, which is correct. Now, if somebody enters 0, for example, say you were getting these numbers from the keyboard, right? So if you enter 0, the program still compiles, but when you run it, you get an error. You get an error that's a very specific one. It says exception in thread main. Okay, this is the main thread. Java line arithmetic exception. And then here's the reason, divided by 0. So we'll call this the message. We'll call this the exception. And we'll call this the stack trace. Basically, where is it coming from? Okay, so the error first originates in main, in exception test.java line 4, which is here. Okay, and then if I show the line numbers, right? So this is line 4, and then from here you read this from the bottom up. So then inside the divide function, line 9, that's where the error was. You can see line 9 is right there, and it says division by 0. So this came as a 0, but there's no way to detect this kind of errors at compile time. Of course, for this simple function, you can check, whether with an if or something, but for more complex functions, it's not that obvious. So what you do is you try to see if you can catch the exception. This is an exception, remember? Exception, message, and stack trace. This whole thing that I have highlighted here is a stack trace. So to safeguard against these exceptions, what one can do is to use the command try. This is a try block. You open try block. And in the try block, there are all the commands that might produce errors. You put them in a try block. And then you say catch. And then you see this name here, arithmetic exception. Well, we're going to catch that kind of exception. Whoops. Then we catch this kind of exception. So arithmetic exception, which is a class, E. And then when we catch this exception, we'll say system.out.println division by 0. Okay, so let's compile this. Oops, there's one error. Now here's an error, right? So it's missing the return statement. So return A divided by B. So if I catch an exception, what I can do is return -1, for example. Okay? So I'll compile this and run it. And you see that in my division by 0, it says division by 0, because this is what I print when an arithmetic exception occurred, and then -1. Another thing that I can print, I can say division by 0, so that's my reason, and then I can say exception. Remember, it's in a variable called E. So E.print stack trace. In this way, trace, no, I had a typo, trace. In this way, I won't lose the stack trace in case there's an exception, so I'll know where it actually occurred. So if I run it, here's the stack trace, right? So my message division by 0, followed by the stack trace, followed by the -1, which is what I return here, and print over here. So we're safeguarding some elements here. The other thing that I can do is I can have a variable. So this is another case that sometimes happens. You have some variable, result. It's going to store whatever your application should return. So we can say here, result equals A divided by B. And here we'll say return result. Okay, return result. And then when we catch the exception, we can return -1. Okay, we can return -1. Okay, but then we can also, you know what, we can take out this whole thing. We can just catch the exception and return -1. And then we can have another part of this try and catch, which is the finally block. The finally block gets executed no matter what. So we're returning result here, we're returning -1 here. Now finally, system.out.println division completed. Okay? So notice that I'm returning here and returning here as well. Okay? And then what I can do here is say result equals -1, return result. So then we have the same code here. If it's A divided by B, and this is if it's -1, right? And then what I can do in the finally is print out division completed, result, and then my variable result. What's happening here is that no matter which element returns, the result or the exception, I will still say division completed, result, whatever. So I'll still print the message because finally gets executed no matter what in the exception. Notice how I have return statements before it, but this is the thing about finally. So if I run it, it says, you see, division completed result equals -1 because there was an arithmetic exception because I'm trying to divide by 0. Okay? I return the result, but in the finally block, I can do everything else that I want even after the returns return. And one of the things that usually happens, some people, for example, say you're accessing a database and there's an exception in the database. What happens is here you would probably close all the connections and make sure that the database is closed regardless of what was an exception or not. The same thing happens for files. We'll see when we look at input-output that you'll have to try and catch exceptions, and you can have a finally block to set to close all the files and don't leave any things hanging. This is try and catch a finally. Another thing that you can do is, let's simplify this again. Result equals 0, result, let's say result equals A divided by B, and then return result. What happens here is that this will compile, but we'll get an exception, right? We get the exception in here. Now what I can do here is I can say this method throws arithmetic exception. I am telling Java that this method might throw an arithmetic exception, meaning an arithmetic exception might happen inside here. And what I do when I say throws here is what I'm saying is that I don't want to handle that exception here. I want it to be thrown to the method that called divide. Now the method that called divide is main, because within main there's this output, right? And this is the call to divide. So the compiler if I give this is a hint for the compiler too. If I say that and I try to compile this, the compiler, oh yeah, it won't complain, but if I run it, okay, it says that I have an arithmetic exception here, right? It also says it. So what does the throws by me? The throws, what I'm telling it is that somebody else is going to handle the exception. So my method stays very lean, but when I call my method, I need to try and catch the arithmetic exception. And then in my arithmetic exception E, I will say, you know, something like system.out.println division by 0. Okay, so I'll compile this. I'm not going to use a finally block here. Finally blocks are rare, I have to say. So run it, and then it says, as we expected, division by 0. So I can have the exception within the code of the method, or I can code a very clean method and have the try and catch when I actually call that method. Okay. The last thing that I want to tell you about this is, say for example that I have this integer a equals new integer parse integer 3, and integer b equals new equals integer dot parse at least parse int 0. The parse int 2. This is parse int, and this is not new. Okay, so I have a and b, and then I'll divide a and b. This is very silly code, but for example, I might use a parse int when I'm reading from the keyboard and I want to parse that integer, right? Or when I'm reading from a graphical user interface, I will be reading stuff as integers, and I need to convert them into ints, okay? This is the way you do that. So let's try this one. Oops, cannot find symbol. Oh, parse. I have a little spelling error. Parse it. Okay, compile. Let's compile, and it'll run. It'll be 3 divided by 2, which the result is as expected 1. Now, what happens if by mistake, say the person entering the keyword enter the letter T? Remember, there's a try and catch block right here. And you compile it and run it. Whoops, there was a big exception here. Exception. Number format exception for input string T, meaning number format exception means that I try to convert something to a number that was not a number. In this case, it's the string T. And that is not an arithmetic exception, so it didn't go in here. What I can do is have multiple catch blocks to catch every possible exception. So the other exception that I can receive is number format exception, and cannot be called E, so NFE. And then I will say system.out.println I can't divide if you don't provide 2 numbers. Right, so now I'm catching an arithmetic exception that might happen, which is division by 0, and number format exception. Now we know this is a case of a number format exception because I have a T there. So I'll run it, and it says I can't divide if you don't provide 2 numbers, because now it caught the exception. Okay? Now exceptions are subclasses of the main class exception, but just the name. So I can say catch exception EX, and then say system.out.println something else happened, right? And this is a catch-all because exception is the father of any of these other exceptions. So number format exception is an exception, and the arithmetic exception is an exception. So Any other exceptions will go here. Now, the exceptions that are caught are in order. So if I say t, the first exception that happened is the number from an exception, right? But if I divide by 0, I'll cut the divide by 0. If two exceptions were to happen, the first one A2 cannot happen, but if you had a catch-all exception, an arithmetic exception, the more specific one is going to be caught first, unless you have the catch exception at the top. So remove this catch exception here. The first exception that matches basically is the one that is caught. So if we move it here, oops. If I say catch exception, any exception, in here, and something else happened, even if I have a number format exception, this one will be triggered. So let's see. Oops. Oh yeah. So the compiler is not letting me. It's saying there's no point in catching this because it's being caught already up here. So, in sum, exceptions allow you to track errors that you wouldn't otherwise anticipate. Okay. For example, when there's user input, that might be prone to errors. And exceptions can be either can surround your method, can have a finally block, or they can be thrown by methods, in which case the color, in this case this guy, the color should try and catch exceptions, and you can catch more than one exception should that happen. The next time we're going to see input and output, which uses exceptions heavily.